Running the simulation, to do it, the first thing you do is you have to specify random variables, and for that you use the define distribution wizard or type them in. Then you have to specify an objective or a target variable, and you have to make darn sure that your random variables are feeding into that target variable, or when you run a simulation you're going to get a very strange result. To set the objective variable, you highlight the targeted cell, you click Add Output icon, and then you either accept or edit the name, and you definitely want to put in a name that's going to make sense to you, because as you build these models, sometimes you'll have more than one output variable in a given model, or you'll have more than one worksheet with output variables in them, and you're going to want to keep track and know what those different output variables are. So definitely give it a name that makes sense, and then you click OK. So we've defined our input variables as random variables. We've defined the output variable. Now we click on the simulation settings and specify the number of iterations. Typically 1,000 will be enough. We've already seen the sampling tab, and it's going to sample via Latin Hypercube. And if you want to watch it, you can go over to monitor. This doesn't When it's just a table that you're looking at, it's not terribly useful. Sometimes if you're running a graph of what you're doing of the random variables, you can watch the graph change as the simulations run through, and that can be fairly interesting. Then you click Start Simulation. If you've previously run a simulation, so you still have a results window open, At-Risk is going to ask you if you want to save the previous results. You can say yes, but the problem is some of these previous results will take up to 50 megabytes, so you can quickly fill up a hard drive, even a large one. So just say no. Remember, all you need to do is run another simulation and you have the results again. Once you've run your simulation, the results screen opens automatically. It lists the inputs and the outputs, and it lists a few summary statistics, and then it gives you just an incredibly powerful number of options to take a look at your results and analyze them. If you want to bring up the histogram, you have several different ways to do that. You can click on the output variable that you're interested in and then click the graph icon. Perhaps more useful is just figure out the variable that you're interested in and then right-click on that variable's name, and it brings up a really interesting menu of potential options. So let's run one of these things and take a look at the results. So here's our EBIT model as we've seen before. Now remember, we set it up so that our sales is referencing the draw over here, and we've defined draw as a normally distributed random variable with these parameters. We've defined the cost of goods sold as a normally distributed random variable with those parameters. What I haven't done yet, I don't think, no, I haven't defined this as an output variable. How do I know that? Well, I can go up here in the formula bar, and I don't see anything there that tells me that this is any kind of a risk variable. So I've highlighted this cell. I want to make this an output variable. So I'm going to click on the Add Output. It's asking me what I want to call it, and I'm going to call this for now EBITDA uncorrelated, because in the next video we're going to look at adding correlation. Click on OK, and now you can see At-Risk has added new language here, risk output, and the name is within parentheses. Now one of the nifty things is if I don't like this name, as long as I stay within the parentheses, I can change the name and edit it any way that I wish. We are done. It's now time to run a simulation. So we check the simulation settings, and they're set for 1000. That's what we want. Cancel that out. You just punch this button here, Start Simulation, and then in the lower left-hand corner you'll see the simulation window pop up, and you can watch how quickly it goes through here. Okay, there's the message. Do I want to save the results? No, I don't, because I like free space on my hard drive. And in a blink, it's done. That was 1000 draws and recalculations. The output variable that we want to track is the one we just created, and that's in the V3 running the simulation worksheet, and you can see it's EBITDA uncorrelated. I'll drag this across so you can see the full name. Now the way to bring up the histogram, which is why we're doing this, you can either highlight it and then go up here to the graph icon and click on that, and it gives you quite an interesting array of options. The first is a histogram. I'll bring this over. And a histogram is going to be like a bar graph. If you don't like that look, I'll close this. You can hit the graph icon and go over to the area graph, which is my preference. And now you see the area graph here. It's just the same thing, only it's smoothed out a little bit. Now, as long as this is open, I'm going to increase the size of it. And we can start doing some fairly nifty things. Let's bring this center stage. Remember I said you get a lot of information from these graphs, and they are interactive. And one way to do it, say if you want to control probabilities, you can drag these lines back across, and you can go, oh, okay, what are the odds that I'm going to get an EBITDA less than 0? So I've dragged this over until I see a 0 here, and it tells me 1/10 of 1%. Not too bad. What if I want a 95% confidence interval? Well, I can drag these until I get 2.5%. And I'm looking at this window here to get 2.5%, and you can see it's pretty tough by dragging alone to get to 2.5%. I can try using these arrows and move it, but again, they move in large increments. So how do I get exactly 2.5 in this box? I go over here to where it says left P for left probability and type in 2.5. So there's the 2.5%. That means there's a 2.5% chance of getting an EBITDA less than 107. And now I want 2.5 over here. Well, this is cumulative across here, so I need to type in for my right probability 97.5. So I move down over here, type in 97.5. I'd make the fonts darker if I could, but I can't. Hit enter. Now you see 2.5 here, 2.5% here, 95%. So now I've created my 95% confidence interval, and it's going to be somewhere between 107 and up to roughly 316. What if I wanted to find the probability of an EBITDA being less than or equal to 150? Well, I can drag this over until I get to 150. Right here is what I'm looking for, and it tells me that that probability of an EBITDA less than or equal to 150 is 12%. What is that 12%? Again, remember, this is a distribution, so the area under this graph, this purple space, sums to 1. And the area between this vertical bar and the graph, this purple triangle with a funny shape here, it comes or sums to 0.1203 or 12%. So that's where that comes from. What if I'm interested in the possibility of an EBITDA greater than 300? Well, I drag this over until I get to 300 down here, and this tells me I have a roughly 5% chance of getting an EBITDA greater or equal than or equal to 300. Let's close this out. There are two ways to bring up the histogram. The other way to do it is simply to right-click on the variable that you're interested in, and you can see it brings up the options of a histogram or a cumulative distribution or a tornado graph, and we'll talk about that later, or a quick report. So let's go over to the histogram and select area graph, and you can see it brings up the same interactive graph that I had before. So either way works. In the next video, we're going to talk about how you add correlation to your models. In this model, we assumed that sales growth and cost of goods sold were drawn independently. That means you could have years when sales growth was really high, but cost of goods sold was really low. You may have reasons to believe that that's not correct, that if you have a year in which sales growth is really high, that there's going to be a strong demand for the raw materials that are going into your product, and that's also going to increase the prices of those products. So in which case, high sales growth would be correlated with high cost of goods sold, or associated with high cost of goods sold. In that case, you would want to add correlation into your model. We're going to look at that in the next video.